All right, so we've been using sine and cosine and tangent to find to set up ratios. We're going to use that now to help us solve for angles that are unknown. This is just a review problem from what we did the other day. Aiko stands 5 meters from a tree, so let's kind of draw our picture here. Here's the tree, 5 meters away, 5 meters. The at that distance, the angle of elevation from the ground to the top of the tree. So this angle is 80 degrees. Find the height of the tree. That's missing in this, but find the height of the tree. So I'm going to call this X. So this is our given angle. And it looks like I'm dealing with the opposite side and the adjacent side. So let's see, my reminder. So katoa. So the function that uses opposite and adjacent is tangent. So I'm going to set this up. Tangent of 80 degrees equals the opposite, which is x over 5. And this is the hypotenuse. The hypotenuse is always across from this is the hypotenuse. So I wouldn't use sine and I would use cosine because both of those require you to know the hypotenuse. I guess there are some times when you can, if you're looking for the hypotenuse and you know one of those sides. But in this case, that information is not given and we're not looking for it. So, okay, so I need to solve for x. So I'm going to multiply both sides by 5 times 5 times 5. I'm going to plug this into Desmos here real quick. So 5 times tan of 80, and I get 45. So 45, that could be reasonable. I do want to make sure that, like, if I were to get a negative number over here, I know for sure it wouldn't be reasonable. 45 feet high might be. 80 degrees is a pretty steep angle, so that is reasonable to me. One of the things I want to make sure you do is make sure your calculator is in the right mode. So I'm going to go and check. Actually, my calculator right now is in radians mode instead of degrees. So I'm going to change it over to degrees mode. And 28.35 does seem to be a more reasonable number, although 45, I mean, I don't have a reason of knowing that it's not correct. But again, that was, if you click the wrench here, and way at the bottom, it says which mode that you're in. So we do want to be in degrees mode most of the time when we're working with triangles. So x turns out to equal 28.356. I'll round that up to 28.36. So 28.36. It is important at the end to check to make sure that it's a reasonable number. I always like to make sure that we determine, is that reasonable? Does that make sense? Okay, so this is kind of building on that same idea, but this is kind of working in reverse. So what we want to do here is, this is an example where we're given some information. Now we're given two sides of it. And the question is, what is the length, what is the size of angle C? So similar approach, right? I'm asked about angle C. I'm given, with respect to C, 6 centimeters, that's the side opposite C, and 8 centimeters is the side that's adjacent to C. So opposite and adjacent, I should be using tangent. Again, up here, the SOHCAHTOA thing, this is another case where tangent's the appropriate function. Although, since I know two sides of this right triangle, I could solve for the hypotenuse pretty easily. I could use Pythagorean theorem. So 6 squared plus 8 squared equals C. Let me call it a little a squared. Why did I call it a little a? Because this angle over here is angle A, capital A. So then using the proper labeling of a triangle, I should call this lowercase a then. And this side down here, it's 8 centimeters. It would be lowercase b, and this would be lowercase c, although it looks a lot like my uppercase c. Okay, so if I'm trying to find c, trying to do the least amount of work, tangent's appropriate here. If I knew that, let me finish this out. 36 plus 64 equals a squared. A is going to turn out to equal 10. So now that I know that this is 10, I could use sine. I could use cosine. But we usually like to use the given information. We're less likely to use incorrect information if we do that. So tangent's the best. So tangent of, in this case, I don't know what the angle is. I'm trying to find the angle. So tangent of C equals 6, the opposite side over the adjacent side. And if you want, you can reduce that to 3/4. Okay, so this is where it's a little bit not tricky, but you got to really kind of think about your algebra here. So I'm trying to solve for C. I need to get rid of tan. Tan's not like a number I can divide by. Tan is a function, just like squaring is a function, just like raising a number to a power is a function. So I need to undo that. If it were squared, I would take the square root because that's what undoes squaring. What undoes tan is tan inverse, pretty much. I'm just going to leave it at that, pretty much. So tan inverse of tan of C, these will cancel each other out, and it will pretty much leave me with C. So I took tan inverse of the left side. I need to take tan inverse of the right side. So tan inverse of 3/4. Tan inverse of 3/4. This now it's ready for the calculator. So I'm going to go here and I'm going to do, let's see. In order to get tan inverse, though, I need to use the built-in functions here. So I'm going to grab my, oh, geez, I don't see any of the trig functions. Oh, go into functions. And then, oh, look, there's tan inverse, also called arctan. So I want tan inverse of 3/4. So 3 divided by 4. And it tells me 36.87. So does it make sense? Is that reasonable? Could this angle over here be around 37 degrees? And actually, I know it's going to be the smallest angle because it's across from the smallest side. So 37, that seems reasonable. So I'm going to say C is approximately 36.87. Okay. And you have to use approximately when you are taking the value of a tan inverse or a value of tan. Usually they're not typically going to be exact values. We're just going to have to round off at some point. That's why approximately is more appropriate. Let's take a look at another one here. Okay, so here I'm trying to find the value of J. Okay, so I have this side over here, 5, and I have this side over here, 16, and this is, they should have drawn it in. It's a right triangle. So with respect to J, 5 is the opposite side, and 16 is the hypotenuse. So I'm dealing with the opposite and the hypotenuse. So which one of these uses opposite and hypotenuse? Oh, it's this one here. It's sine. So to set this up, I could say sine of J equals the opposite side, which is 5, over the hypotenuse, which is 16. And just like the last one, I need to get J by itself. In this case, it's J. I need to get rid of sine. Sine is a function. I need to undo that. That's the inverse function. So I'm going to take the sine inverse of both sides, sine inverse. Okay, and so sine inverse pretty much cancels out J. I keep saying pretty much, and there's a reason why. You got to be a little bit careful when we talk about bigger angles, but for a right triangle, it does. It will always work. So J is exactly equal to sine inverse of 5/16. I didn't use approximate because this is exact. Once I take the value out of the calculator, then it'll be an approximate rounded off value. So I'm going to grab my calculator here and bring it down, and I need to do sine inverse of 5/16. Okay, so here, let me get rid of that. I'll go back to my functions, and there's sine inverse, and then we'll do 5 divided by 16. And we'll get 18 degrees. Seems pretty reasonable. It's going to be the smallest, probably. Very likely it'll be the smallest. If I were in radians mode, look and see the value that I get when I'm in radians mode. 0.3. 0.3 doesn't make sense for this angle. How could it be 0.3 degrees? It's actually 0.3 radians. It's a different way of measuring an angle. And we'll look at that later on in this chapter. So degrees, when we're dealing with triangles, degrees is appropriate. So J is approximately, at this point now, I use approximately. J is approximately 18.21 degrees. Okay. If I wanted to find L, I can use subtraction at that point, or I could use cosine inverse. If I did cosine of L, that would equal the adjacent, which is 5 over 16. 5 over 16. Well, wouldn't I get the same thing? No. When I do cosine inverse of 5/16, let's do that here. Functions, cosine inverse of 5 divided by 16. We know we're going to get something that's close to, what is it, 71? 16. Yeah, we get 71.8, right? Because we knew this one was 18.2, so this one's going to be 71.8. So I could have found that by subtraction, or I could have done cosine to do that. So cosine inverse. Okay, that's your quick little lesson on that. It's not that hard, but you have to set it up and put those numbers where they are, and you got to know SOHCAHTOA.